Hello, good morning. If you can hear me and you can see the instructions, you can leave. So today I'm going to finish chapter 10. And I don't know when you guys your midterm will start, but then the midterm would be on the 10th slide. That's the data introduction to data warehouse. So that's going to be on the whole concept. After that, then we'll treat 2 or 3 topics before the final exams. Yeah. So um, let me see in the comment section if you can hear me. Just write your name or you type yes. You type yes for me to know indeed you're following and you can hear. All right. Okay. So that's good enough. One person's comment is good for me. So from the last time we actually met, we looked at schema, or let's say the preparation of the fact table, and how it's supposed to done, and I gave you what to do, where you're supposed to develop the second and third normal form for the superstore database that I gave you guys. When we meet next week face to face, I'll be looking at that, so you can keep that for now. So today I want us to finish and then start off with what a surrogate key is. Now, a surrogate key, and it usually dimensional table should be surrogate key. All right. So when you pick a dimensional table keys, it should be a surrogate key, something that is non-intelligent and non-business related. Why? Because um, the business may change over time, and it also helps keep track of non-key attribute values for a given product key or production key. Surrogate keys are also simpler and shorter, and surrogate keys can be same length and format for all other keys. So the primary key of a fact table is typically a composite key of all its foreign keys. In most cases, when you pick a fact table, it's the primary key that have been aligned on the table that will put together to form the primary key. Then let's a grain of the fact table. So granularity of the fact table. So what level of details do you want with regards to the fact table? Should we have a transactional grain? That's the finest level. Aggregated grain, more summarized. Final grain, better market basket analysis capability. Final grain have more dimensions tables, more rows in a fact table. And there is a web-based commerce. That's the finest granularity. So the term grain or granularity refers to the level of details a fact table determined by intersection of all the components of the primary key, including all foreign keys and other primary key elements. All right. So Kimball and others recommend use of smallest grain possible, given the limitations of the data mart technology. Even when the data mart user information requirement imply a certain level of aggregate grain, often after some use, users ask more detailed questions. That means they drill down as a way of explaining why certain aggregated patterns exist. You cannot drill down. And so fine grain means higher volume of data. Then we look at the duration of database. All right. So normal duration is usually 13 months or 5 quarters. A quarter is 3 months, so a year. We're looking at 5 quarters. That's going to be, if it's a year, then we're looking at 3 plus another 3. That will be 15 months. Then we have financial institutions may need longer durations, and older data is more difficult to source and clean. So the more the data gets old, the more difficult it is to actually source and clean such data. So depending on the number of dimensions and the grains of the fact table, all right, the number of rows can be determined by the product of the number of possible values for each dimension associated with the fact table. Right. So when you check the textbook, you could see figure 9, 11. The textbook I've given you an example there. So total rows calculated as follows. Assuming only half of the product record sales of a given month. So we have a total number of stores as 1,000, then a total number of product as what? 10,000. Then the total number of period will be 24. That is 2 years worth of what? Monthly data. The roll is equal to total, that's the stores by the active product, and then the number of months, which will give us 120 million rolls. That's a lot. All right. Yeah. So this is a fact table containing time period data. So this is based on the diagram. And so when you check figure 9.12, you'd see how the fact table and then all the dimensions are aggregated together, are put together. So because data warehouse and data mart record facts about dimensions over time, date and time is always a dimension table. And a date surrogate key is always one of the component of primary of the primary key. All right. And so this is one of the reasons we consider data warehouse to be time variant, because it always have the time and then date as part of what the dimensions. Someone said they can't hear, which was quite interesting. Still waters. Okay, good. He says he can hear now. So note that the dimensional table includes many non-key attributes. All right. So the non-key attribute includes all the characters of the date that use to categorize or summarize and group facts. Right. So there is a question that could be in this model. Can you use, or can you say, what can you say about how many events could be associated with a particular date? So based on the model you see, how many events is associated with a particular date? In this case, we are looking at the relation between events here, the event table here, and then the date dimension. So based on this relation, all right, what can we say about how many events could be associated with a particular date? Yes. Yes, any comment in the section, in the comment section. Elizabeth, I can see from my screen clearly. I'm also watching on my phone. No one is commenting. Okay, so when you look at the relation between event and then the date dimension, then we can say that only one. All right, so one event or each time dimension is linked to only one event within the event table. So when you pick a date, it is linked to one event. Now, variation of the of schemas. So there are multiple fact tables, right? So multiple fact table can improve performance, often used to store facts from different combination of dimension, and we have to it is conformed to those dimensions. Then we have the factless table, where no non-key data but foreign keys for associated dimensions, and that is used for tracking event and then what, inventory coverage. So here we see a typical situation where multi-fact tables have two related star schema. All right, so in this example there are two fact table, one of that's one at the center of each star. So sales fact, we have sales fact about sales of product to customers in a store on a date, and then we have receipt. That is a fact about receipt of a product from a vendor to a warehouse on a date. So these two schemas are connected with a common dimension, date. The term for this is a conformed dimension. So conformed dimensions are dimension tables associated with two or more facts table for which the dimension table have the same business meaning and primary key with the fact table. So when you look at this, we have a factless fact table. So the question is, why would you want a factless fact table? So generally, for the same reason you want to associate entities. This is to maintain relation between dimension tables. So here we see the use of attendance facts table containing nothing but foreign keys. This is useful for tracking events, especially tracking which student attended which course at which time in which facility with which instructor. All right. So the attendance fact table is being used as what, the factor, because it can easily link all the various dimensional tables together. Now, although fact tables are normalized, often dimensional tables may not be. This enables dimensional tables to be only one join away from the fact table. So improving query performance. Of course, non-normalized data involves data duplication. So a question can be asked, why is this not a problem? So why is the fact that non-normalized dimensions could be linked to a normalized table, why because the data warehouse is not volatile. In other words, we can't change it. So data doesn't change like transactional process database. So even if it's not normalized, we know it's not going to change. No update is going to affect it. Then we have the multi-dimensional or multi-valued dimension. So although fact tables are usually on a many side of 1 to n relationship with their association dimension, there are circumstances where facts may need to have a many to many relationship, m to n relationship. In a data warehouse, this is facilitated through the use of a helper table, which is associated, which is an associative entity between the fact and the dimensions. So let's look at slow changing dimensions. So how many knowledge in the past? That is something we can look at. Then Kimberly's approach is type 1 is use. Just replace old data with new. That is the loss of historical data. 2, for each changing attribute, create a current value field and several old valued fields. That is multi-valued. So we create the third type is create a new dimensional table row each time the dimension objects change, with all the dimension characteristics at the same time of each. This is the most common approach. So this means we're creating more of a 3D dimension so we don't have to remove old information. All right, it is there, and then we just create a new dimension, and that dimension will take care of the new um, data that is coming and its own characteristics. Any questions? Good. So this is an example of a 2 CSD customer dimensional table. So you notice that in the last part we have the SQL commands, for that. There's a dimension segmentation. Right. For rapid changing attribute, approach creates too many rows, too much redundant data. So we use segmentation instead. 10 essential rules for dimensional modeling. Use atomic fact, create single processing facts, include a date dimension for each data. All right. Enforce consistent grain. It's allow now keys in fact table. Honor hierarchies, decode dimensional tables, use surrogate keys, conform dimension, balance requirement with actual data. So use atomic fact. So eventually users want detailed data, even if their initial request are for summarized fact. And that's why we need to have that. So creating single process fact table. Each fact table should address the important measurements for one business process, such as taking a customer order or placing a material purchase order. Then we include date dimension for every fact table. That is, a fact should be described by the characteristics of the associate day, that is the time and date to which the fact was related. Enforce consistent grain. Each measurement in a fact table must be atomic for the same combination of keys. Then we said disallow null key. So fact apply to the combination of key values and helpers tables may be needed to represent some many-to-many relationships. So 6, we have honor hierarchy. Understand the hierarchies of dimension and carefully choose to snowflakes the hierarchy or denormalized into one dimension. Under the code, then we have 7, the code dimensional table. So store descriptions of surrogate key and code used in a fact table in associate dimensional table, which can be then used to report labels and query filters. Use surrogate key. All dimension table rows should be identified by a surrogate key with descriptive column showing the associate production and source of the system key. 9, confirm dimension. So here, confirm dimension should be used across multiple fact tables. 10, balance requirements with actual data. Unfortunately, source data may not precisely support all business requirements. So you must balance what is technically possible with what users want and then need. And the last thing we look at is the future of data. Now, there is the issues of big data, that is huge volumes and often unstructured data. And then there is the issue of what? Speed of processing, design, purchase, database, and networking aspects in tandem, right? Use of memory, in-memory database, that's the RAM instead of the disk. We also have add analytics capabilities closer to the original data source instead of separating data warehouse. So that's what means that we are looking at performing historical work closer to the database itself. And that's another thing. Then the cost of storage, right? Where data warehouse now moving to cloud, and then optimizing storage by using what? Columnar databases. Then we have unstructured data, where we have the NoSQL, right? So in that case, we're not using SQL. We have the Hadoop, etc. So vendors making advance in these areas include Teradata, Oracle, SAP, Microsoft, IBM, Amazon, and these guys are, taking data warehouse into a higher level. So that is that. Please, do you have any question? Yeah. So that is that for this section. That is, and that concludes the on chapter 10. So you have to go in and go through everything, and I think most of the midterm will be based on chapter 10. Any question? Looks like no one is bringing up a question. It's okay. So I'll end the section, and I will be sharing. I think the video will be available for you guys to use. So prepare for the midterm. Wish you all the best.